friends, welcome back to the channel. Simulation is a tool by which you can replicate the actual chip before it is manufactured. That means that the functionality of the chip can be verified with the help of simulation methodology. Simulation methodology comes in the design phases after you can call synthesis, or even it can come after RTL parsing. Why? Because if you have a RTL level abstraction of a particular design, you can run this in a simulation tool. You can generate some output that can be a behavioral level input, and you can generate some output from these, and you can store this output as your golden files. So obviously after verifying this output is correct. Next thing is that the synthesis is basically nothing but converts the behavioral level model to the actual logic level model. Actual logic level is nothing but when you write some behavioral level logic, like for a flop, you have an intent to create a flop, you have an intent to create a latch in the RTL. Maybe you put some code inside this always block and try to replicate that into a flop. In the synthesis, basically you map this logic to an actual logic gates like DFA for latch. So these are called the synthesized netlist. It also contains a lot of nets, lot of wires to connect this kind of things, and also it incorporates library standard cells in this netlist itself. Now the interesting point is that when we write a synthesized netlist as a tool output, you do not know whether it is correct or not, whether it is matching with the RTL level abstraction. So how to validate that? With the simulation it becomes very simple. With that, you run a simulation tool with the RTL level abstraction and you generate the output. You know that this output is correct, and you validate that with respect to the functional specification of the design. And then you run the same RTL with the synthesized netlist, and you generate the with the RTL and generate a synthesized netlist. And this synthesized netlist you can run with the same simulation tool, and you can generate some output. Now you compare these two output. This output should match. So that is basically the synthesis and simulation consistency. So that means that the synthesis tool has correctly mapped all your behavioral level logic to the actual synthesized netlist. So then your synthesis view and your simulation view both are prepared. So in my previous video I talked about the parser view. Parser view is nothing but abstracting the interface level information. So now till synthesis you have a parser view, you have simulation view, you have synthesis view. So all these views should be consistent with each other. And now beyond that, there can be some other views in the methodology from RTL to GDS2 that I will talk in my next videos. But with that, I think you should have some information about what is the design abstraction or design information particularly encapsulated. There can be numerous representation of the same design logic, but the consistency is very important between or among all these abstraction of the design things. But not the least, I would like to share that I have published a book, Semiconductor for All, which basically caters all these semiconductor innovations and the technologies, and also its application on electronic design automation and other fields like robotics. And also I have covered the manufacturing of semiconductor technologies. So if you are interested about semiconductor, if you are interested about artificial intelligence, I would highly recommend that you purchase this book from Amazon. This is the Kindle version. I will provide the link in the description of this video. And last but not the least, before signing off, I would like to tell that if you have any feedback about this video and about these topics that I have to discuss today, you can drop comments and I will try to answer those comments. So with that, Subhasish Chakraborti signing off.